Hello, my name is Keith Kaufman, and this is my high school senior design project presented in video format. So, before I get into the design itself, I need to introduce a little of the theory behind it first. The staple of the project is the superconductor. A superconductor is a material which, when cooled below its critical temperature, Tc, will have no electrical resistance, and this has some interesting electromagnetic properties. As the superconductor is cooled past its Tc, it expels all magnetic fields from its interior via electrical currents on the surface. As you can see illustrated in this diagram, no field lines pass through the interior of the material, but instead bend around it. If you set up the field correctly when you transition it, then you can achieve levitation. This illustration is a very nice one for this because it happens to be the actual orientation of magnets that I use in my design. The magnets are oriented north, south, north in order to produce a field which is oriented such that it provides both vertical and horizontal stability. If you put these magnets into a long track, the superconductor can move freely along them because the field remains the same along its entirety. This technology has already been developed to be used in transport vehicles. However, what I aim to do here is to use the same principles to propel the vehicle as well. This would eliminate the need for additional propulsion systems to be added to the track, like linear induction motors, and would instead utilize the superconductors which are already present. Because there is a restoring force whenever the superconductor is in a different region of the field, you can alter the field to exert a force on the superconductor. In this illustration I made, a superconductor is suspended above a track which is divided into sections. The small line represents the magnetic field in that it remains the same along the track. Each of the dark green rectangles represents an electromagnet which can be activated at will. When you activate one of these electromagnets, it will alter the field and the vehicle will feel a repulsive force which seeks to return it back to its regular field. This repulsion can be used both for acceleration and deceleration depending on the direction of travel. So, that being done, there's still the job of determining the location of the vehicle and turning it into useful information to control the track. I decided to use a sensor-emitter system, in which each section of track has one sensor associated with it, and the vehicle has emitters mounted on it.